So as we begin this section, we're going to start talking about rational inequalities. So in the last section, we defined a rational expression, and I just want to remind you of what we said that was. Remember, rational means that it's a ratio, which means it's a fraction, where you have a polynomial function on the top and a polynomial function on the bottom. So we're going to take this idea of a rational expression and we're going to put it in an inequality, which means that we would put it in a problem that either has a less than or greater than, or a less than or equal to or greater than or equal to. So our first problem, we're going to start with an easy one, says that we have 4x plus 5 over x plus 2, and we want to know where that rational function is greater than or equal to 0. So what we're going to do is we're going to take the numerator and the denominator and look at them separately in terms of finding the zeros. So I'm going to take the 4x plus 5 and I'm going to set that equal to 0 and solve for x. Right, so in doing so, I'm going to need to subtract this 5 from both sides of the expression, which is going to give me 4x is equal to negative 5. And then to get x by itself, I'm going to want to divide both sides by 4. So the 0 that goes with the numerator of my fraction is going to be negative 5 over 4. Now I'm going to do the same thing with the denominator of the fraction. So my denominator of the fraction is x plus 2. I'm going to take that expression, set it equal to 0, and solve for x. So again, we're going to want to subtract the 2 from both sides. And then in doing so, we have x is equal to negative 2 as the corresponding 0 for the denominator of the fraction. So what I'm going to do is I'm going to take those two values and I'm going to put them on a number line. You want to put them in order. So negative 2 is the smaller value between the two. So I'm going to put negative 2 here. And then I'm going to space out a little bit and put the next biggest value, which would be negative 5 over 4. You do want to be sure that you get them in the right order. You don't have to put other numbers on the number line unless you want to, but you need to be certain that you have the values that you came up with for your zeros in sequential order on the number line. Now, the idea is that these two zeros, remember these are your x-intercepts. So these are the places where the graph is going to cross the x-axis. And so I don't really know what this graph looks like, but let me show you this really quickly. Like if we have negative 2 here, I would anticipate that the graph is very likely to run maybe from a positive number here and then cross and become a negative number. Right? Or vice versa, it might have started negative and then crossed and became positive. And so if that happens, we have a part of the graph where the graph is positive and a part of the graph where the graph is negative. And so we see that that change occurs at those x-intercepts. And so what I'm going to do is I'm going to check on either side of that negative 2 and see what happens to my function. So I'm going to choose a test point. I'm going to pick a point that is less than negative 2, maybe, and you can choose anything you want, but I'm going to choose negative 3. And then I'm going to check a test point on the other side of the negative 2. All right, and I want to be careful that I don't end up on the other side of the negative 5 over 4. So negative 5 over 4 is essentially negative 1.25. I'm just going to note that up here so that I am careful with what I select. So I need to pick something that is on the other side of negative 2, but not so far that it would be negative 1.25. So I'm going to just choose maybe negative 1.5. All right, now what I'm going to do with those two test values is I'm going to plug them back into the original problem. All right, so my original problem is 4x plus 5 over x plus 2. And so I'm going to plug these two values into that expression. So let's do the -3 first. So in place of the x's, I'm going to be plugging in a -3. All right, and then let's see what we get. So 4 times -3 is -12. Plus 5 is going to give me a -7. And then in the denominator, -3 plus 2 is going to be a -1. So -7 divided by -1 is going to be +7. Now, I'm not so concerned about what value I get, whether it's a 7 or a 9 or a 10, but what I'm concerned about is whether it's positive or negative. So since that 7 is positive, I'm going to come right here to my graph, and I'm going to put a plus in that section of the graph. And essentially what that means is that any number that I picked, if you had picked -4 or -6 or -10, anything in that section should produce a positive answer when you plug it in. All right, so let's do the same thing now with the -1.5. All right, so I'm going to take my function 4x plus 5 over x plus 2, and in place of those x's, I'm going to put in -1.5. All right, and then we're going to work that out. So on the top part, I'm going to use my calculator here. 4 times -1.5 plus 5 gives me a -1. And then on the bottom part, -1.5 plus 2 gives me 0.5. And when I divide that out on my calculator, that's going to give me -2. And so again, I'm not that concerned that it's a -2 because you may have selected a different value. Maybe you didn't pick -1.5. All right, but we should all have negative answers coming out when we plug those values in. So what that tells me is that the graph, when it hit -2, it was positive, it was above the x-axis, and when it crossed over the -2, it crossed down into the negative part of the graph. All right, now I want to do the same thing at -5/4 to figure out what happens at that 0. So I already know that coming into -5/4, the graph is below the x-axis. So let's see what happens above the x-axis. So I'm going to pick another test value. I need something bigger than -5/4. So I'm going to go with 0. 0 is an easy one for me to plug in. And then again, I'm going to go to my original problem. And in place of those x's, I'm going to plug in my test point, which is 0. Again, you can choose any test point you want as long as you are above -5.4 or -5/4. And then we're going to work this out. So 4 times 0 is still 0, and plus 5 would be 5. 0 plus 2 is going to be 2. And again, we're really concerned with whether that answer is positive or negative. So anything in this section of the graph should produce a positive result. Okay, so we've kind of said a lot there. Let's summarize just a little bit. Remember, take the numerator and the denominator, find your zeros, put those on a number line. You're going to choose a test point in each of the sections of your number line, plugging those values back into the original problem, determining whether the answer is positive or negative. All right, the last thing that we're going to do is we're going to look back at the original problem, and we're going to see that we were looking for places where our graph was greater than or equal to 0. So we say to ourselves that numbers that are greater than 0 are positive numbers. And so now when I look at my graph, I want to shade the sections of the graph that are positive. So I'm going to be shading this part, and we kind of color in this arrow to indicate that it continues in that direction forever. So I'm going to shade this part of the graph because that's a positive part. And then I'm also going to shade over here because this is a positive part. And the only other thing we need to do to this graph now is to determine whether we have open circles or closed circles on the actual zeros. So if your problem, and I'm just reviewing this with you, if your problem has a less than or greater than that has an equal to underneath it, you're going to use a solid dot because that means that that number is included in your answer set. If it's just a greater than or less than but no equal to, you'll use an open dot. And so in this case, because we are greater than or equal to, we're going to use a solid dot on the 2 and a solid dot on the -5/4. And so you should also be prepared here to write your final answer in terms of interval notation. So you're going to start from the left, and this interval begins shading at -infinity. Remember, infinities always get a parenthesis. And it shades all the way to -2. -2 is included, so we use a bracket. Right, we're going to union that, put that together with, and we'll start again here at -5/4. Again, that's included in the answer set, so we'll use a bracket. And we'll shade all the way to +infinity. So on these problems, we're going to be looking for 2 ways to write your answer. You're going to be writing it on a graph like we've done, and you're also going to be writing that answer in interval notation. All right, so I'm going to try one more problem with you. We want to do one that's maybe a little bit more complicated. This one came straight out of Newton, so hopefully it will be similar to what you'll be seeing there. All right, so our function is x squared plus x minus 12 over x squared minus 4x minus 12. And again, we're going to take each part of that and find the zeros. So I'm going to start with the numerator, x squared plus x minus 12. I'm going to set that equal to 0, and I'm going to solve. Now this is factorable, so I'm going to do it that way. So to make the x squared, we would do x and x. To make the 12, we would use 4 and 3. Because we want our middle term to be positive, we want the bigger number in our parentheses to be positive. So we get it factored, and then remember that you're going to set each of those factors equal to 0 and solve. So we have x plus 4 is equal to 0. We have x minus 3 is equal to 0. And so subtracting 4 from both sides would give me a 0 at -4. And then on this one, we would add 3 to both sides, which would give me a 0 at 3. Okay, then we do the same thing for the denominator. So we'll take x squared minus 4x minus 12. We'll set it equal to 0. This is also something that we can factor. So x and x, to make the 12, we'll use a 6 and a 2. Because the middle term has a negative, we want our bigger number to be negative. We'll then set each of these terms equal to 0 and solve. So we're going to get x is equal to 6 when we add 6 to both sides. And we're going to get x is equal to -2 when we subtract 2 from both sides. Okay, so now we have the zeros. Remember that those numbers are going to go on a number line. So I'm going to draw my number line. And I'm going to mark off those 4 values. Remember, you want to mark them off in the correct order. So -4 would come first. Then we would have -2. Then we would have 3, and then we would have 6. And so we see now that our number line gets split into 5 sections. We're going to select a test point in each section. All right, so we need something that is smaller than -4. You can choose anything you want. I'm going to choose -5. We need something between -4 and -2. I'm going to go with -3. We need something between -2 and 3. I'm going to use 0. Between 3 and 6, I'm going to do 4. And bigger than 6, I'm going to use 7. Again, what you choose to use for the test value, that is completely up to you. All right, so once we have those test values selected, we're going to go back to our original problem and we're going to plug those values in. And I would encourage you here to use your calculator as much as possible to make this process easier. All right, so I'm going to begin by plugging in a -5, and I'm plugging in a -5 back into this original problem, and I'm plugging it everywhere there's an x. So I'm going to have -5 squared plus -5 minus 12. And then on the bottom, -5 squared minus 4 times -5 minus 12. All right, and again, keep in mind that the only thing that you're really concerned with here is whether you get a positive answer out or a negative answer out. All right, so I'm going to use my calculator. And I'm going to simplify the top part of that fraction. So that's going to give me a +8 on the top. And for the bottom, it's going to give me a +33. All right, and so 8 divided by 33 is a positive number. And so what I'm going to do now is go to my graph, and in place of that section, I'm going to say any number coming out of that section would be positive. Now I'm going to move and do the same thing for the -3. So everywhere there's an x, I'm going to put in a -3. And we're going to do the same thing. So as we plug in that -3, we're going to have on the top a -6 and on the bottom a +9. So again, we're going to get a negative number there. I don't really care what negative number, just knowing that it's negative. I'm now going to plug in a 0 in place of the x's. And so that's going to give me a -12 over a -12, which is going to be a +1. So we'll put a positive in that section. The next test value that we're plugging in is going to be a +4. All right, so on that one, we'll get a +8 on the top. And a -12 on the bottom, which is going to give me a negative result. And then finally, we're plugging in a 7. Which is going to give me a 44 for the top and a 9 for the bottom, which again is going to be positive. All right, so once you complete your table, then the next thing that you're going to do is you're going to come back to your problem and you're going to look here and you're going to ask yourself what kind of numbers are less than 0. And so we know that numbers that are less than 0 are our negative numbers. And so that means that we will shade the negative sections of the graph. And because we have this equal to underneath the less than, we know that at the points where we have the endpoints, we should have solid circles. Now, the only thing that you have to pay attention to here, because this is a rational inequality, is that you need to make sure that you are not including a number in your solution set that would be undefined in the original function. So as you remember, when you have a fraction, you need to be sure that the denominator of the fraction never equals 0. So let me think about that for just a second. I need to be sure that x squared minus 4x minus 12 never equals 0, because if it does, then my function is going to be undefined. Okay, so remember, I'm going to refactor this just for a second. You would have it in your notes. Remember that the zeros that came out of this were x is equal to 6 and x is equal to -2. So if I were to take a 6 and plug it into the denominator of that fraction, the bottom part of the fraction would turn into 0 and I would have a problem. So what I'm going to do is come back to my graph, and in place of that solid circle on the 6, I'm going to have to put an open circle. And again, I have to do that because if I include 6 in the answer set, then I'm going to have an undefined value in my fraction. I'm going to need to do the same thing on the -2. So that solid dot that we originally put there needs to come in and be an open circle, because -2 would cause the denominator to equal 0. All right, so once that's done, then we are ready to write our interval notation. So remember that you're going to write an interval for the shaded parts. So our first shaded part starts at -4 and it has a solid dot, so I'm going to use a bracket. And it shades until we get to -2. -2 has a open dot, so we'll use a parenthesis. For the last one, we'll start at 3 with a bracket because we have the closed circle, and we shade to 6 with an open circle, so a parenthesis. And so now we have the solution set for our rational inequality.